Hello, welcome to 6.2. I think radicals are going to get a lot easier. I really like this section, so let's talk about it. Okay, like I said, we're in 6.2, and we're talking more about these rational exponents or radical signs. So we're going to learn kind of a new way of writing it, and I think it's actually a lot easier to write it this way, and it's a lot easier to do math this way. And so here we are. We're looking at our radical exponents, and we have an exponential form, like right there. And this means, this part right here, means the nth root of a. So we're taking a and we're raising it to a fraction of an exponent, and this means, the nth root of that fraction. So notice the nth root, it's the number on the denominator. So we can actually rewrite that to make it look like something we're more used to seeing is, so if we're looking at the nth root of a, that's also n with the little radical sign for a. So these two things are the same. So we can rewrite each one of them just like the other one. And this is super helpful because these nth roots behave just like fractions in an exponent. So remember all those exponent product rules, sum rules, all that good stuff? When you multiply exponents together, you just add the exponents and we're good to go. So that works with these, and that works with these as well if you just turn them into fractions. So it's super helpful in my mind, and I think it makes a lot more sense. And you can also do powers and roots raised at the same time. So that's when you would get a fraction like that. So this is the nth root of a raised to the mth power. So let's rewrite that into something that we're a little bit more used to seeing. So that would be like n radical a raised to the mth power. So there you go. Let's do some examples. Okay, step one, we're going to convert from one form to the other since this is kind of a new thing. So we're looking at number one, that's the fourth root of x. We would write that as just like that. So we're converting from exponential form to radical form. So remember, this is your exponential form. Everything is in an exponent. This is your radical form because the house thing is a radical symbol. So that's where all my radical jokes come from, man. Anyway, write each expression in radical form. So I'm on number two. So we can say 24 cubed root of that. We also want to simplify if needed. So 24 can be divided into 8 times root 3, cubed root 3. And then 8 can be then reduced to 2. And again, if you didn't know that, do your little factor tree. But this time, since we're doing cubed root, you need 3 factors that would work. So number 3, that's going to be a square root. Just so we don't have to actually write the 2, but remember the 15 and the x make it inside of the radical sign. Sometimes you'll even see me do something like that. That just shows the end of the radical sign. It's not required, but it's just a habit I got. Okay, now we're into some fun ones. So now we've got a fraction here. So this would be like just squaring something, and this would be taking the cubed root of something. So we can write that as the cubed root of 7 squared. So 7 squared is 49. So then I would, of course, look to see if 49 is reducible. It is not, so we are good to go. Okay, so looking at number 5, we have an exponent and a root. So if we're going to rewrite that, we're going to do the square root of k to the 7th. Now you don't necessarily need to write the 2 there. If you do, it's not really wrong, but it's just not commonly done. Now, the fun part is that in previous lessons, I would have said, hey, think about how many how many k squares can you get in there? And so you can say that, oh, I can get 3k squares. So like k6 would be 3k squares. So then k to the cubed comes out and you have 1k left over. Something like that. So that is the answer. But another way to think about it, and one of the reasons that I like this fraction thing so much, is that you can kind of think about it as a fraction. So if I look at 7 over 2, actually let's change my color. So if I look at 7 over 2, how many of those 2's can I get, or how can I reduce that? Hey, maybe even here's the chance for all of you to use your mixed numbers that I've been harping at so much. So 7 divided by 2 is going to be like 3 with 1/2 left over, right? So there's 3 of my k's that came out, and then this 1k would be still under the square root. So in my mind, that fractional way of thinking about it is a lot easier than doing the square root thing. Whatever works in your mind works for me. So anyway, if we're looking at number 6, we got 3 to the power of 5 with the 4th root. So if we're going to write that, 4th root of 3 to the 5th power, I intentionally did not multiply all that out because I'm going to use my fractional idea of this right there. So I know at least 1 3 can come out of that. So I'm going to pull my 3 out because, again, I'm looking at this fraction right there. So then after I after I reduce this fraction, the 5 divided by 4, I take one of the fractions out, and then there's only 1/4 left over. So then we're going to have 1 3 left over in there. So again, another way to think about it is my 5 over 4 is equal to 1 and 1/4. So that's like a mixed number. This 1 tells me how many of these numbers comes out of the radical sign, and then this tells me how many is left underneath the radical sign. So again, this 4 is right here, and this 1 would be like right there. So maybe if this wasn't a 1, then maybe I would square that 3 or something like that. But again, that's just one way to think about it, and it's an easier way to think about it for me. So now we're going to start converting from radical to exponential form. So again, this is super helpful for me because then later on when we're doing math, it's going to be a lot helpful to have them in exponential form. So we got cube root of 16. We're just going to rewrite that as 16 raised to the power of 1/3. On 11, we got square root of xy. So we can do xy, note the parentheses, raised to the 1/2. So that's going to be equal to x to the 1/2, y to the 1/2. So number 12, we've got that whole thing. So we're going to just put it in parentheses, raise to the power of 1/4. And then we're going to distribute that 1/4 out. So we've got 8 to the 1/4, which is that a thing? No. I was thinking the cube root too, or of 8. Anyway, so then we've got this w. So the w is going to be now to the 2/4. So let's see if I can move this a little bit. No. I still missed it, but whatever. You guys know what I mean. So note the fraction, the w is now at the 2/4. So we're going to have 8 to the 1/4, w to the 2/4, which you can then reduce that. It's just like a normal fraction. So we're going to reduce that to w to 1/2. So again, the fractions help because you can then treat them like normal fractions, and you actually end up doing a lot more complicated math super easily. So looking at number 13, we're going to have 11 raised to the power of 2/3. I don't think there's much we can do with that. So looking at 14, we've got our 4th root of k. So that's going to be like Well, we'll start up here. K to the 10 over 4. But again, we can take 10 over 4. How many times is 4 going to 10? So at least 2, which will get us to 8. So that's going to equal 2. And then we're going to have 2 left over. Like I said, 8. 2 over 4. And then, so that's going to be 2 and 1 over 2. So that's just kind of like fractional math I'm doing in my head. But that helps me figure out here. Oh, I guess we didn't even have to do that. Never mind. So all we would have to do is just reduce this fraction. I'm sorry for that. But it's a good learning moment. So all we have to do is reduce that fraction. So our final answer is going to be K, what is that, 5 over 2. So again, going into the exponential form, I think is super helpful to do some of this math with, because that fractional math that we love so much can help us out. So I'm jumping down to 19. This is where it gets a little bit more fun. We're actually doing math now. We're not just switching back and forth. So as I mentioned, switching into the exponential form allows us to use our exponent rules. So that's what we're going to do. We're going to rewrite all radicals in exponential form. We're going to use our exponent rules to simplify the expression. And then we can rewrite, looks like they want it in back into a radical form and in simplest form. So here we go. So when we're looking at 19, we're going to use the exponential rules of the product. So all we need to do is add the fractions up. So remember, adding fractions, the denominators need to be the same. In this case, they are. So we're just going to add these two. So our final answer, not our final answer, but our answer is going to be something along the lines of x to the 5/3. So if we want to, we can't reduce that fraction at all. So we're kind of stuck with that. But since I know I'm going into radical form, I am going to do my little fractional math inside of my head. So the thing that I'm thinking about is, okay, 5 over 3, how many times does 3 go into 5? Just once. So if I were to change that into a mixed number, that would be 1 and then 2/3 left over. So if I'm going to then turn this into a radical form, so this is going to equal the cubed root of x, and based on my fractional stuff that I did, we're going to have 1x come out here, and then we're going to have a squared in right there. So again, I'm hoping that you're starting to see how the fractional math is working. So this x came from this number. This number, the cubed root, came from the denominator right there. And then this number came from this number. So again, the tops of the fractions are going to be your exponents. The denominators of the fraction, the bottoms of the fractions are going to be your cubed root. So let's do a couple more. So looking at number 20, we've got p to the 1/4 times p to the 3/2. So in this situation, our denominators are not the same. So we are going to add them, okay? So we know that we're going to add them. So I'm going to come out here and do a little bit of quote unquote like kind of sketch math or whatever. So we want to do 1 over 4 plus 3 over 2. So how are we going to do that? We're going to change this to have the denominator 4. So now we've got 1 over 4 plus, what is that, 6 over 4. So now we're going to have 7 over 4. So our answer here is going to be p to the 7/4. So we need to turn that into a radical form. And so how many times does 4 go into 7? Just once. And then we'll have 3 left over. So that means we're going to have a p on the outside of the radical. We're going to be taking the 4th root. Oh, that's terrible. The 4th root, still pretty bad. The 4th root of p, and we'll have 3 left over after we take out that 4. So again, our denominator went to our radical sign. Our numerator went to our exponent sign. and that number got reduced because we pulled 1 out. So looking at 21, this time we're going to subtract our fractions. So in red, we're just going to do our fraction math. So we're going to have 5 over 2 minus 7 over 4. So we need to multiply this one by 2 over 2 to get some common denominators. So now we're going to have 10 over 4 minus 7 over 4, and that's going to be equal to 3 over 4. So now we can finish out our actual problem. So when we subtract our fractions, we're going to have m to the 3/4. We want this in radical form. So that's going to be 4 radical m cubed. This is a good one to see where everything is going. And hopefully these are starting to make a little bit more sense. So 22 is a power of a power. So remember that rule. So we're going to multiply these two things. Since we're multiplying, we don't necessarily need common denominators. We're just going to multiply across top, multiply across the bottom. So our answer is going to be a to the 5 over 6. And we need to turn that into a radical sign. So we're going to have a taking the 6th root of a to the 5th. So remember where each of these numbers are going. So 23, 24 are both going to be product rules, a power of a power. So power rules. And so we're just going to multiply. So we've got 32. We're going to multiply those together, raised to the 1/4. So that is the same as 4 over 32. And I'm double checking. So let's see here. 16 can come out of that, and that's a 4th root. If I didn't know that, what I would do is take 32, 2, so that would be 15, 16, 2 times 8, and 8 is 2 times 4. So we have, we're at a 4th root, so we need 4 2s, 2, and then 2. So we need 4 of these 2s to come out, and then one of them would stay in. So then our final answer would be 1, 2 comes out, 4th root of 2. So 25 threw a little bit of a curveball at us, but that's okay. We know how to deal with these negative signs right here. So anytime you see a negative sign in a square root, that just means that number is going to go to the denominator, it's going to be a big fraction, it's going to go to a denominator. So this is the same as saying 1 over 100 to the 1/2, which is the same as saying 1 over square root of 100, which is the same as 1 over 10. So the answer to 25 is just 1 over 10. So 26, so we've got a product rule, and we've got a negative sign, but we're just going to follow the same procedure, the same stuff. So we're going to take our 16, and our answer is going to be 16, 2 over 3 minus 1 over 3. So yes, there's a negative sign there, but we're just going to subtract it. So our final answer is going to be 16 raised to the 1/3. And let's see here. 8 is a factor of 16, which is a perfect cubed. So then we can then turn that into 2 cubed root of 2. So again, if you didn't recognize that, which if I didn't know off the top of my head, or if I wasn't looking at the answers or had already looked at these, I wouldn't know. I would have to do the 16, 2 times 8, 2 times 4, 2 times 2, and then do that. So there's nothing wrong with doing that. I would rather you do a little bit of extra work to get it right than look at it and go, I just have no idea what to do. We're going to do lots of examples in class, so I'm just kind of skipping down to 33 to give you guys a variety of problems that you have on this video. So 33, it's in radical form, and I'm just going to immediately turn it into exponential form. That's going to be 10 over 4. And then I know that can then, so this fraction can be reduced. So that's going to be x, what is that? 5 over 2. So then I'm kind of thinking to myself, 5 over 2, if I were to turn that into a mixed number, 2 would go into 5 2 times. So that'd be 2, and then I'd have 1/2 left over. So my final answer, when I should have done that in a different color, but when I put that back into a radical form, is going to be, let's see here, 2x, let me check, x squared. So 2 x's came out, so we're going to have x, so when we put that back into radical form, we're going to have x squared on the outside. This is a square root, and then we're just going to have, let's see, it looks like 1x left over. So again, this 2 went right there. This x went right there. And this 2 went right there. There is no 2 written right there because it's an implied 2. So that's how you do that one. So last but not least, we're going to put 34 into exponential form. And I'm going to distribute it at the same time. So we've got 25 raised to the 1/4 power. And then we're going to multiply that by m. 2 is going to go on top. 4 is going to go on bottom. So I'm looking at this number. See if we can reduce that at all. I'm looking at, let's see here, 5. That's going to be the 4th root. So when I'm looking at this 25, this is kind of a weird way to think about it. My brain doesn't work this way, but you can rewrite 25 as 5 squared. And then that 1/4. So that's also going to then equal 5 2/4, which then you can reduce that as 5 to the 1/2, which is just the square root of 5. So that's, whenever you see these like 25s or like normal perfect roots, maybe try to simplify them that way. I don't know of any better way of thinking about it, but it's just a thing that you're going to have to get used to doing. So our final answer is going to be, we've got the square root of 5, and then this guy up here that m is going to reduce to m to the 1/2. So then that's going to be the square root of m. So our final answer is just square root of 5m. So this one's going to take a little bit of practice getting used to doing this part right here, but I think you can do it.